Good morning, sir. I'm Preeti. I will be the moderator for this session. So let us have a brief introduction about today's session speaker. Good morning, everyone. I welcome you all to the session 5 of day 2. I, Preeti S, take this privilege of introducing our speaker of this session, Dr. Sanjaya Kumar Panda, sir. Dr. Panda is currently working as an assistant professor in the Department of CSE at NIT Warangal, Telangana. He has worked as an assistant professor and head of the department CSE at Indian Institute of Information Technology, Design and Manufacturing, Kurnool, Andhra Pradesh, and also worked as an assistant professor in the Department of Information Technology at VSSUT, Burla. He has received his PhD degree from Indian Institute of Technology, Indian School of Mines, Dhanbad, Jharkhand, and his MTech degree from NIT Rourkela and BTech degree from VSSUT Burla in CSE. He has 11 years of teaching and research experience. He has received 34 awards from IEEE, ISTE, CSI, and others, which includes 2 silver medal awards for the Best Graduate and Best Postgraduate in CSE, IEI, Young Engineers Award, Young Scientist, IEEE Senior Member, and CSI and ACM Distinguished Speaker. He is listed in the top 2% of world scientists in a single year impact as per the survey conducted by Stanford University, USA, and elsewhere in October 2022, 2023, and 2024. He has published 150 plus papers in reputed journals and conferences and edited 7 books. He is a member of IEEE, IEI, life member of ISTE, and life member of CSI. He has received a research and development project of worth 50 lakh from National Supercomputing Mission IISc Bangalore under Department of Science and Technology, Government of India. His current research interests include cloud and fog computing, artificial intelligence, machine learning, and Internet of Things. He has delivered 250 plus invited talks and chaired sessions in many national and international conferences. He has awarded 6 PhD scholars, 26 MTech, MPhil, MCA scholars, and 43 BTech students, and is guiding 10 PhD scholars. His Google Scholar citations reached 2,850 plus with an H index 31 and I-10 index 61. He has acted as a reviewer in many reputed journals of IEEE, ACM, Elsevier, Springer, and Hindawi, and many reputed conferences. He has also served as a guest editor in many international journals. Let us welcome Dr. Panda, sir, and we look forward to have an insightful and engaging session. Over to you, sir.
Yeah, thank you, Preeti Madam,
Welcome.
for introducing me. So I welcome all the participants to this 1 week online faculty development program on research methodology and grant writing in association with the Association of Indian Universities Academic and Administrative Development Center. And I would like to thank all the faculty members of Biju Patnaik University of Technology, Odisha, especially Dr. Chandrasekhar Rao sir, for giving me an opportunity to speak in this faculty development program. And I have 2 sessions in this faculty development program. In the first session, today we are going to discuss about introduction to quantitative analysis. And in my second session, I'll also highlight about different technologies and research trends like artificial intelligence, blockchain, security, privacy, cloud computing, fog computing, and so on. So in this session, we are going to see one of the interesting topic in machine learning perspective, or you can say data science perspective, that is called as quantitative analysis. And as it is an online session, I request participant whenever they have any doubt or any discussion. So please feel free to stop me at any point of time. So, if the topic says quantitative analysis, so normally the analysis is carried out in two ways. One is qualitative analysis, another is called as quantitative analysis. But our topic is specifying to the quantitative analysis. So we should know first what is the difference between qualitative analysis and quantitative analysis. You know, this analysis is purely depends upon the data, and data can be collected from various sources. Like data can be collected from databases, data can be collected from various blogs, data can be collected from various e-commerce sites, data can be collected from social networking sites. So when we collect the data, based upon the data, we can perform the analysis. But if the data which we have collected, the data is not in appropriate form, that means it is inconsistent in nature, so it is very difficult to do the analysis. So whether you do the quantitative analysis or you do the qualitative analysis, all these things are depend on the data. So, in a particular data set, in a data set is represented in the form of rows and columns, and each and every row represent different samples, and each and every column represents different features, or we call different variables. For example, if I talk about this faculty development program, I can maintain this data in a Excel file having rows and columns, in which each row represents a particular candidate and each column represents different features related to a particular candidate. For example, what is the candidate name? What is the candidate email ID? Candidate affiliation? Candidate qualification? Mobile number, and so on. Right. So we represent the data in a very structured form when we talk about the Microsoft Excel file. But in real life data, all these data are not in a structured form. Everything cannot be also represented in the form of a structured form. For example, if you belongs to computer science domain, so you may be aware of some web development languages like HTML, or you talk about XML and PHP and so on. All these are following a particular type of structure, but that is not a completely represented, that is not a structured manner, right? It is in a semi-structured manner. Although all these web development languages follow some kind of syntax, some kind of paired text or singular text, but it is not that much structured compared to a Microsoft Excel file. So analysis in the semi-structured data is different. Now, if I talk about Facebook, or if I talk about Twitter, that is the social media applications, in these the data are completely unstructured in nature. So when the data set is unstructured in nature, then analysis becomes more difficult. So analysis is very easy when the data is in a structured form, but when the data is in semi-structured form or unstructured form, it is difficult to perform the analysis. Right? That's why you have to carry out different analysis based upon what kind of data is available to you. Right? So mostly the data is in unstructured form and semi-structured form. We want to convert it into a structured form before we do some kind of analysis, whether you do a quantitative analysis or qualitative analysis. Now, if you talk about if you talk about a particular, uh, let's say a Microsoft Excel file, I'm taking an example because most of the data sets are represented in the form of a CSV file, which we call as comma separated values file, and we can open this comma separated value file in Microsoft Excel, right? So these files are having different kind of variables. Like I told you, these are nothing but the candidates. For example, if I take about student or a candidate, then I can say, oh, this is first student, this second student, third student, fourth student, and so on. And these are the details related to the student. For example, student name, student, let's say age, student qualification, student email ID, student mobile number, and so on, right? Like that we are capturing the picture, right? So these are treated as the feature, or we treat these as a variable. So when we talk about these variables, So variable may be a numerical variable, or it may be a categorical variable. For example, if I ask what is the temperature today, then you will tell a number, right? For example, the temperature of Raulkala is currently, let's say, 38 degrees Celsius, right? So it is a numerical value. And tomorrow the temperature may increase, tomorrow the temperature can decrease. So when we are taking a numerical variable, we describe quantities of the object of the interest, right? So we look into that. What is the range of the temperature? Let it be minus 2 degrees Celsius to 45 degrees Celsius for a particular location. And every day the temperature varies. So all these things can be represented in the form of a numerical variable. On the other hand, we can also represent some variables in categorical form. For example, if I ask you what is your blood group, so blood groups are predetermined, right? It is already fixed number of categories are there, like A positive or A negative, B positive or B negative, AB positive, AB negative, O positive, O negative, and so on, right? So these are fixed categories. So some variables are in numerical nature and some variables are in categorical nature. Again, if those variables are numerical in nature, so they can also be further categorized into discrete variable, also called as continuous variable. One part is discrete variable, another is continuous variable. For example, if I say number of child's birth per day, so it is a number, it is a counted number. It will not come in decimal, right? Number of child birth is, let's say, 20, 30, 50 in a particular city, right? But when I ask the weight of a person, then somebody can say 75.3 kg, somebody can say 80.2 kg, somebody can say 50.3 kg. So this is continuous. So we need to determine whether a variable is either numerical variable or a variable is categorical variable, right? And if it is a numerical variable, we need to determine whether it is in discrete in nature or in continuous in nature. So with this only you can do analysis in the form of any analysis you want to do for a particular data set. That depends upon the type of variables that are using in a particular data set, right? Now coming to our topic, where I am focusing on quantitative versus qualitative analysis. So quantitative analysis is done when the data are numerical in nature. Okay, for example, if I go for this first set of variables where the data is numerical nature, it may be discrete, it may be continuous, right? So such type of data are, if it is given to you, you can go for quantitative analysis, which is our topic of discussion for this particular session. And it is this type of analysis is quantified into hard facts. Hard facts means if I ask you whether we will go for a party today or not, your answer should be either yes or no. Where I am representing yes by, let's say, 1 and no by, let's say, 0. That's why it is said hard facts. Similarly, I can give you an example. If I say, did you buy ice cream today? So your answer should be either yes or no. And if I am asking this question to all these participants, those who are attending this particular program, then let's say 67% of the participants respond that they want to buy ice cream today. So this analysis is done based upon the hard facts, whether it is yes or it is no, right? But when you go for qualitative analysis, which is not the interest of this particular session, but I am telling you so that you can differentiate these two whenever you are going for such type of analysis. So when you go for qualitative analysis, there is no numeric data. So you have to deal with non-numeric data. For example, if you take a Facebook post, in Facebook post there are several comments, right? In a Facebook post there are several comments are there. So you need to determine whether a particular comment is a positive comment or a particular comment is a negative comment. Let's say I want to analyze the sentiment of that particular post. Okay, positive or negative or neutral, you can say, right? So all these things I cannot represent in numerical, because user write a set of text, from that I need to analyze to decide that whether it is positive, negative. So it is not that much easy compared to if I ask you a question whether you take ice cream today or not, right? So in that case, you can go for qualitative analysis. So there we deal with numerical data and numerical data describes qualities and opinions or feelings. So it is very difficult to do qualitative analysis, but it is easy to do quantitative analysis. For example, like I mentioned, did you buy ice cream today is an example of quantitative analysis. If the same question I'll ask in a different manner, why did you buy ice cream today? So your answer should not be yes or no, right? In that case, why did you buy ice cream today? So you will give a reason that I want this ice cream because I decided to take this today, or I want to take this with my friends. So this is descriptive in nature, right? We describe what is the reason of taking the ice cream. So in that case, we are going for qualitative analysis. So mostly those analysis are asking about how many, how much. So in that case, you go for quantitative analysis. And those cases you have why you have taken this one. Then in that case, you can go for qualitative analysis. So obviously, I can say quantitative analysis is objective, whereas qualitative analysis is subjective. Like that, there are different kind of differences between the quantitative analysis and qualitative analysis. Another example, if I give here, for example, if I want to do a painting, so if I go for quantitative analysis for a particular painting, then I need to specify what is the width and height of the painting, what is the area of painting, right? And so such type of things I need to mention. But when I go for qualitative analysis, I need to decide which color I have to use for painting. What is the cost of this painting? What kind of colors I am going to use? What is the quality of these colors? And so many things I can ask related to the qualitative analysis. So this is the basic difference between a quantitative analysis and qualitative analysis. To summarize these two definitions, you can say when you deal with the numeric data, you will go for quantitative analysis. But when you deal with the non-numeric data, like categorical data, like marital status of a person, or you can say blood group, as I mentioned, political party which you like, eye color of human being, all these are called as categorical data. In that case, you can go for qualitative analysis rather than going for quantitative analysis. Now, as a researcher, whether you are a research scholar or a faculty member, so when we do the research, so what kind of analysis is required? So, in fact, we require both type of analysis. We need quantitative analysis as well as we need qualitative analysis. But those people who are working in the area of machine learning and artificial intelligence, or mostly those areas, or data science, okay, and so many related areas, people focuses on quantitative analysis rather than qualitative analysis, right? And you can also convert qualitative analysis to quantitative analysis. For example, I'll ask what is the marital status of a particular person, and based upon the marital status, I am assigning a particular number. So I can convert it, right? So in order to do this qualitative analysis, there are different kind of packages that are available, right? So basically in this session, I will highlight about some of these packages. So these packages are called as, first one is called as SPSS. SPSS stands for Statistical Package for Social Science. Okay, it is a very popular package. In old days also, means before this data science becomes very popular, these SPSS tool is also available and many people have also used it. But now, as it is not restricted to social science, normally in social science we do conduct some kind of surveys, we are doing some kind of reportings. So in that case, we are using SPSS. And SPSS tool actually it is given by IBM company, right? And it is not open source. The biggest drawbacks of this SPSS tool is that it is not open source. You have to subscribe it, and you will get a trial version for 7 days, right? If you want to install SPSS in your system. And due to its use, or it is a, you can say it is a most popular statistical package, and which can handle very complex data manipulation, analysis, task, and so many things. So many advantages are there. Nowadays, people say it is statistical product and service solutions. Earlier, it is called statistical package for social science. Now it is called a statistical product and service solution. Okay, so what kind of things you can do in the SPSS? SPSS case, if you go for SPSS case, SPSS allows you two different type of view. One is called as data view, another is called as variable view. Okay, if you install SPSS in your system, anyhow, you will get only trial version until unless your institute has subscription to SPSS. So if you open SPSS, you will get there are two view. One is called as data view, another is called as variable view, right? And there are different type of variables, like I told you about categorical variable, numerical variable. All these are supported in the SPSS tool. For example, gender of a person, okay, male, female, or transgender. These are also different. This is called as nominal variable or different categorical variables that is supported by this SPSS. So SPSS has a lot of advantages, and I told you it is one of the oldest statistical analysis tool that is used in the research. And if you want some kind of mathematical measures like standard deviation, mean, sum, minimum, maximum, variance, range, and let's say kurtosis, skewness, all these are supported by SPSS system, right? So I'm not going in detail about SPSS because it is not open source. That's why most of you will not have a chance to explore all the types of functionalities that are available in SPSS. And it is also used for the data visualization technique. What do you mean by data visualization here? Data visualization means if you want to go for bar chart, you want to go for line chart, you want to go for pie chart, or you want to go for histogram. All these things can be done in the SPSS. But SPSS is not used by many people. That is the reason is that they don't have any subscription, right? But as an alternate of SPSS, we have another two tools that are very popular, and most of you also know these two. One is called as R, another is called as Python. And this R and Python, these two are open source. So you need not pay any amount if you want to install these two software into your system. Okay, you don't need any subscriptions. So that's why R and Python is very popular. And you know nowadays, due to this machine learning application or data science application or artificial intelligence, these two tools or statistical packages are very, very popular. But as I am focusing on different kind of analysis, so R becomes very popular for statistical analysis compared to Python. But anything done in R that can also be done in Python, and vice versa is also true. Whatever done in the Python that can also be done in R. There is absolutely no difference between R and Python. But most people, those who are data scientists, they are analyzing the data, or they focus on different patterns. They focus on R rather than the Python. But it is up to you. If you have expertise in R, then you continue your statistical package analysis or any analysis you want to do using R. If you are habituated with Python and its syntax, you can go for Python, right? So let us discuss about these two tools in detail in rest of the time. So for R, I have given two different links in the chat box. All of you can see in the chat box. I have two links. I will show you that. So you need to install these two software in your computer. Okay. One is R Interpreter. The first link is R Interpreter. You see the latest version and download it. Once it is successfully downloaded, then you need to install R Studio. Okay. And we are writing the code for code. Any code you want to write, you can write directly in the R Studio, right? And R Interpreter will work in the background, and R Studio will work in the front end, right? So in my system, I have installed all these two software. And while installing this software, there is a path setting is required. So in order to avoid that path setting, make sure that once you have successfully installed the software one, okay, which is R Interpreter, then you will start installing R Studio. So don't install these two things simultaneously. Okay, you first install the first thing. Once it is successfully completed, then you start installing R Studio, so that there is no need of any path setting. And there is no explicit setting. Simply you have to click next, next, next to install this software. So once you open this RStudio, once you install this RStudio, so if you open RStudio, you will get a screen like this. Okay, so this is the initial screen you will get, or this is nothing but a console of RStudio. Okay, so I'm using R version 4.1.1, but you can use any version, right? There is no absolutely no difference if I use the older version or newer version. Obviously, newer version has more flexibility and it has solved different kind of bugs, but you can explore a different type of things related to uh, different versions. You will get the same thing, same kind of features you will get more or less. Some errors may be fixed, but more or less you will get the same thing. Now what I'm going to tell you, I am making you familiar with R. Once you are familiar with R, I'll tell you that how to do the analysis, right? So in R you can see the initial window is divided into three parts. One is the console, okay, this part. Another is called as environment. Another is called as the files, plots, packages, right? And this is the environment. Let me clear my environment. So when you create a particular variable or create a particular vector, that will be shown in the environment. Okay, and if you want to draw any kind of plot like a bar chart, pie chart, any chart, that you will get in the plot. If you want to install any particular package, you can directly type here and it will be installed. Okay, and in order to clear the console, this is the some initial message it is showing. In order to clear the console, you can press Ctrl plus L. Okay, if you press Ctrl followed by L, so it will clear your console. So let us see some initial basic commands that how R actually works that you can find here. So if I want to print a particular message, for example, I want to print, and let's say BPUT Raulkela, right? So simply I have to write print BPUT Raulkela in double quote, or you can write BPUT Raulkela in single quote also. And if you press enter, then it will print BPUT Raulkela and it will show the line number is 1. Okay. And if you want to add to number, so in C++ we are writing a program for adding to number. Here you simply write print, let's say 2 plus 3. So it is going to calculate 2 plus 3 is equal to 5 and it is going to print 5. Somebody wants to, let's say, add two numbers having decimal numbers, for example 2.3 and 3.9. Then if you press enter, it is 6.2. So from these two, what you can infer is that R is not taking any specific type of data type. Like here you can see I have taken integer, here I have taken floating numbers or double numbers, but it is not impacting. I have not mentioned that what kind of variable the command should take. Okay, based upon your input, it is automatically invoking that what is the things that it is going to take. But if you write print within double quote 2 plus 3, so it will be treated as a message. Okay, so in the output screen, it will print 2 plus 3 double quote. Right? Anything mentioned in the double quote is that will be treated as uh, a message, right? And if you are not putting double quote, it is going to evaluate it based upon that. It is going to show you the output. And R also supports a different kind of comments. For example, if you want to write a comment, let's say I am giving a comment as BPUT Raukela, so it will not print anything. So any comment you are writing, it is represented in hash symbol. So this is a single line comment, right? I'm using a single line comment. But if you want a multi-line comment, so simply you can use uh, if let's say false. You know, false means it will not enter to the if statement. And suppose I'm writing this is a demo for multi-line comments. Okay, so okay, I pressed enter. That's why it is coming. Okay, multi-line comments. So I'm going to the next line, and it should be put inside either either a single or double quotes. Okay, something like that, right? If I put some message, whatever message I want, I can put here. And if I close this one, then it will be considered as a multi-line comment, right? It is, you can see it is considered as a multi-line comment. So you can use if false because there is no syntax for multi-line comment. So what we are doing, we are writing if false. So all these statements are not going to be executed. So this is the basics related to R, and R has different objects. So variables are, as I mentioned, variables are not declared as some particular data type like integer, floating point, and double number. So rather than they are declared as based upon the user input, right? So variables are normally assigned in R as a R object. So there are different objects that are used in R. They are nothing but we can use a vector, you can use a list, you can use matrix, you can use array, you can use factor, you can use data type. So I'll tell you about these objects, then I'll tell you that how to do the analysis. For example, if I am writing v is equal to, v is a variable which is equal to true. Okay, so v is equal to true. And if I print what is the class of v, print the class of v. Okay, so v is a true means it is having two classes, either it is true or it is false. So it is a logical data type, right? So if I print class of v, so it is returning me logical. Okay, but the same v, if I write 23.5, right? And if I print the class of v, then it is now showing the class is numeric. So based upon the user input, it has to declare the data type. There is no specific data type that we are declaring before writing any code. Like here you can see, when I say it is true or you can say false, so it is treating that variable as a logical. But when I am using a decimal number 23.5 or a floating point number, then it is treating that as a numeric, right? Similarly, if I write v is equal to 2l, okay, v is equal to 2l, and if I say print class of v, then you will get the class type is integer, right? But when you write v is equal to, l is used for the integer representation. Similarly, I can assign v as a complex number. You know, complex numbers are written like this: 3 plus 2i. Okay, 3 plus 2i is a complex number. So in this case, if I print class of v, then it is in complex. So you can the same variable is logical, same variable is numeric, same variable is integer, same variable is complex, and so on. Right? There are different type of data type that you can use. And in R, there is an interesting data type that is called as a vector. In mathematics also, I think all of you have studied what is a vector. So vector also available in a R. So in R, if you want to create a particular vector, for example, I want to create a vector. The vector name is called as apple, and vectors are declared in R using a C function. Okay, vectors are used in R which is C function, right? C is a predefined function. For example, I can say that apple can be red color, or apple can be green color, or apple can be yellow color, right? For example, right? So here you can see I have created a vector in which there are three colors I am using, that is red, green, and yellow. Okay. Then if I print apple, right? Because apple is a vector which is having three different colors, so it is showing that it is red, green, and yellow, right? And if I want to check what is the class of this variable apple, like the way I am finding for the variable b. Similarly, if I find print class apple, so it is saying it is character type, right? Because all these are characters. So in C we have a different meaning for character, different meaning for string. Normally character we consider as a single alphabet, right? And string is nothing but a group of alphabet. But in this case there is no difference between the character and string. Okay, they are used alternatively. Okay, for example, red, green, yellow. These are called as string in C and C++, right? But in this case, we are using red, green, yellow. These are called as the character, right? So it is a very important function. C is an important function for analysis perspective. Whenever I go to the analysis, I'll show you that how this C function is actually used. Similarly, in our case, we have a list. Okay. For example, if you want to declare a list, so the difference between you can say this C function and list is that list contain heterogeneous data type. It can contain many different types of element, but the C function contains similar type of element. For example, I am declaring a list one, which is equal to list is predefined, and I am declaring three things. I am declaring 253 is nothing but different numeric values. So here you can see I have taken red, green, yellow. These are nothing but the characters. But here I am taking 253 is a numeric vector. So vector may be numeric, vector may be character, right? So, but in list as it is contain many different type of elements. So I am taking let's say 21.3. I am taking let's say a sine function. So I can add anything, right? So if I enter, so it is showing it is a list. For example, if I print my list one, which contain different type of elements, so you can see it has contained three things. One is it contains a numeric vector that is 253. Another it is contain a floating point number or a double number. Another it is contain a function that is sin x. Okay, that is a function sin x. So you can see here are supposed two different type. One is a vector, another is a list. So whenever you want to take the similar type of elements, in that case you can go for similar type of element case you can go for vector. But when you want to go for dissimilar type of elements, you can go for list. Whatever you have seen here. So it is nothing but combining multiple vectors, right? I can say I can take a numeric vector, I can take a numeric vector which is of decimal type, I can take a character vector. So all these things can be combined as a list. That is the difference. Now there is another type in R that is called as a matrix. So all of you know matrix in Microsoft Excel is also treated as a matrix because there are number of rows are there and number of columns are there. For example, I am taking M is a matrix, okay, and in order to declare a matrix, you can use matrix command, matrix function, and in matrix function, I am mentioning the element again using the vector. Okay, so whether you use a list or you use a whether you use a list or you use the directly the vector or you use matrix. So all these cases we are using the C function only. So I am declaring a C function here. For example, I am taking different alphabets like A, let it be again A, then let's say B, and let's say C, and B and A. So I'm writing six different elements A, B, C, B, A. So there are six elements, right? So I have to mention that how many rows are there, because in matrix, if you have a six element, it may be a 2 cross 3 matrix, it may be a 3 cross 2 matrix. So you need to mention what is the number of rows. So number of rows is mentioned as n rows. So for example, here n row is equal to I am writing 2 and n column is equal to let it be 3. So it is a 2 cross 3 matrix, or you can make a 3 cross 2 matrix also. And you need to mention whether I need to read this element row wise or I need to read this element column wise. So by row is equal to true means I am going to read this element row wise. So AAB are coming in row 1 and CBA is coming under row 2, and there are three different columns. Okay, so there is a error. Let me check what is the error. N row is equal to 2. It is seeing error in the element N row. Okay, I have written row spelling is wrongly as N row. Okay, so N number of rows is equal to 2 and number of columns is equal to 3. Now, if I want to print M, okay, so it will be look like a matrix. Like here you can see it is AAB in the first row, then CBA in the second row. This way we can represent a particular type of matrix. Similarly, if I go for by row is equal to false. Okay, by row is equal to false means I am going to print this matrix. I am going to print this matrix column wise. Okay, so in this case you can see AA. If you see this one, it is reading column wise. AA, then BC, then BA. So you can decide whether you want to read this matrix row wise or you want to read this matrix column. Based upon that, you can decide. So matrix is one of the popular data type that is available in R. The next data type that is available in R is called as array. For example, I want to create an array A is equal to. So array is a predefined function. So in which suppose I want to mention again a C function with two color. Let it be green color. Another is, let's say, yellow color. Okay, and I'm mentioning my dimension of the array is equal to 3, 3, 2. Okay, 3, 3, let's say 2. Okay, so this is my array. So if I print the array A, then you can see it is a three-dimensional matrix, right? Normally we represent matrix in row and column, but here I represent in 3 dimension, right? So it is a combination of 2 3 cross 3 matrix. So it is a 3 cross 3 matrix. It is also another 3 cross 3 matrix. Okay. So is the last parameter indicates that how many 3 cross 3 matrices are there? That is 2. So it is repeating green, yellow, then again green, yellow, then green, yellow, again green, yellow, and green, right? So similarly, yellow, green, yellow, green, yellow, green, yellow, and green, yellow, right? Like that way, it is repeating the pattern between the green and yellow. So this way we can represent a array in our programming languages, right? So what we studied till now, we have studied that there are different type of data types. So we have seen what is a vector, what is a list, what is a matrix, what is a array. There is another two data type that I will tell you. One is called as vector.
Hello.
Yeah.
Sir,
Yes, please.
You are choosing only two elements in the matrix, green
Yeah.
and yellow.
Yeah, you can increase it also.
Okay, you can choosing two elements, so we can differentiate into 2 to the power 9 512 type of matrix. If
No,
it
no,
is 3
here,
cross 3 matrix.
yes, 3 cross 3 matrix, but the parameter is 3, 3, 2. So it is going to print two matrix only.
3 3?
3, 3, 2. 3, 3 indicates that number of rows is 3, number of columns is 3, and I want 3 cross 3 two matrices.
That things I am telling you, sir. 3
Ah,
if it is 3 cross 3 matrix and your element is only 2, then
yes,
there is a possibility of a 512 type of different type of matrices.
that is different thing, sir. But here what it is doing, it is printing the same color to fill this 3
Yes.
cross 3 matrix. Like I have
Okay.
given green and yellow, so it is repeating the pattern green, yellow. Then again you can see green, yellow, then green, yellow, green, yellow, and green. So this pattern is repeated to fill up this 3 cross 3 matrix.
Okay.
We are not looking into what are the different kind of possibilities of generating this matrix. Simply we are following green, yellow, green followed by yellow to fill this particular matrix.
Okay. Okay.
Okay. So this is one data type. Next data type that we are going to discuss, that is called as factor. So for example, if I write, let's say, apple underscore colors, okay, a variable can be written like this also, apple underscore colors, okay, in R, which is equal to, suppose I am writing a C function in which I am mentioning the color is, let's say, green. Again, let's say green. Let it be yellow. Okay, let's say next is red. Then next one is also red. Then again red. Let's say again it is green. Okay, so different colors I have selected here, right? Okay, so you can select different type of color. So in the case of apple colors, so that it will be treated as a vector. Somewhere I did wrong. Yeah. Yeah, whenever you are writing a color, you will get the respective color. If you are not getting the respective color, means there is some character is not fetching. Yeah, now it is coming. Yeah, now all the colors are coming. So this code is correct. So apple underscore colors. Now what I want to do, I want to go for factor. For example, I am writing factor underscore apple is a variable. Okay, which will keep the factor of apple underscore colors. Okay, so I have taken how many colors? I have taken total 7 colors. Okay, I have repeated some elements like green is repeated 2 times, 3 times, and red is repeated 3 times, and yellow is repeated 1 time. And I am writing factor of apple colors. Okay, so if I print this factor apple, factor underscore apple. So what it's going to do? It is going to give you the green, green, yellow, red, 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 green, whatever you have mentioned here. But it is also showing that what are the unique colors that are available in a particular list. Right? Sometimes whenever we are doing analysis, we want to avoid the redundant element. Okay. So when we remove the redundant element, in that case, we can use this factor. Okay. So it stores the vector along with the distinct values of the elements in the vector as levels. Like here you can see, although I have repeated green multiple times, red multiple times, when it is showing the levels, it is showing only the unique colors, right? And if you want to print how many colors we have, simply you can write print n level, n levels, then vector underscore apple, right? So this will give you the number of level is 3. Okay. So when you want to, for example, you want to analyze that in a particular data set, in a particular column, how many unique values are there, you can simply use factor. So factor will give you what are the unique values that are available in this column, and also it is going to show you how many unique colors, how many unique values also it is. It is not only printing what are the unique colors, but it is how many colors are also, that is also it is showing. So this is another data type that you can use when you are going for different statistical analysis. The last data type that I am going to show you is called as data frame. Normally, data frame is represented in the form of a tabular data object. Like when you want to display the result in a tabular form, we go for the data frame, right? For example, suppose I'll say I want to print gender, I want to print height, weight, age of different people. Then I can go for data frame. For example, in order to calculate body mass index, all of you know BMI. BMI is based on height, weight, and other weights and other factors, right? So if I want to go for data frame, BMI is equal to data dot frame. It is a predefined one in which I have to mention, let's say gender is equal to, I want to take 3 people data. So I am mentioning gender is equal to male. Let's say second person is also male, third person is female. So this is one column. In one first column, the heading is gender, and the 3 different data, 3 samples I am keeping. One is male, male, and female. Now in the second one, I want to take height is equal to, for example, first person is having height 152, second person is having 171.5, then say next person is 165. So second column it will create as a height and keep these three values in line with the three different samples, right? Similarly, okay, so it is showing error because I pressed enter. Okay, so next is if I go for, let's say, weight of the three persons. So weight is equal to C of 81, let's say 93, let's say 78. Some random values I'm writing, and age is equal to, let's say I'm taking another vector C function. Using a C function I can take a vector that is 42, let's say 38 and 26. So when you print this BMI, so it will be print in a tabular structure. For example, you can see this is a tabular structure, right? So where first column represents our gender, second column represents our height, third column represents weight, fourth column represents age. Okay. So and the corresponding data, whatever you have given, the same data is displayed here. And you can see here I have written 152 and 165, but one of the value I have taken is 171.5. So it is a double value, right? So it is forcing other two values as a double value. What is the reason why it is showing? Because I told you C function is used for similar type of elements. If one element is double type, other elements are forced to be double type. That's why it is putting extra 0.0 into these two numbers. If I write this one is 171, these three things will be taken as a integer, right? Otherwise, it will be converting everything into a similar structure. That is the advantages of going for this C function, right? If you don't want to do this one, simply you go for list. Okay. So this way there are different type of data types that is available in R program, right? So now what I'll do is these basics. I'll tell you that how to do this statistical analysis. But before going this or that this statistical analysis, if you have any questions related to this data type, you can ask. Any participant having any questions related to up to this, you can ask. Okay, otherwise you can type in the chat box also. Okay. Okay. Otherwise you can ask in the question later also if you want, whatever convenient to you. So with this basic, I'll tell you some of the important aspects related to R. So normally we write this thing in the console, and you can see in some cases I am getting error, right? Why I getting this error? Because by mistake I pressed the enter. So it is not suggested to write everything in the console. Although I have written all these things in the console, so we need to avoid this one. So for this, what you can do, R provides you script. So you can go to the file and create a R script. So R script will help you to make it flexible. Suppose you press enter, it will go to the next line. So it will not cause any error. So whatever code that I'm going to write now, that I'll write in the form of this particular script, right? So let me save this script in my desktop with some name. For example, I am giving the name is statistical. Okay, and here you can write the code, right? So for example, if I want to show you the relationship between two variables, like mostly in the research case, we want to analyze whether one variable is dependent on another variable or not, right? In that case, you need to analyze two variables. So how to do that particular type of analysis that I am going to show you now. For example, you are given with a particular variable and it's a set of values, and you are also given with another variable with set of values. You need to establish the relation. For example, here I am doing a variable is x. It is having a numeric vector. This variable is having a numeric vector. So for numeric vector, I am using C function, and the values are 95, 85, 80, 70, and 60. Okay, these are the five values. Similarly, I have another variable y. Y is equal to C of 85, 95, 70, 65, and 70. Okay, so you can see I have taken a variable x with 5 different elements, and I'm taking y with another 5 elements. Right? Just I want to establish the relationship between x and y. Right? So what I'll do? So there is a function called as lm. In R provides a function that is called as lm. Lm stands for linear model function. Linear model function help us to establish the relationship between two different type of variable. Right? So I will write here lm y tilde character x. So this tilde character you can find before the numeric key 1 in your keyboard. If you see your numeric key 1, before that there is a tilde character. So lm y tilde character x. So let us keep this in another variable called as z. Okay. So what is y tilde character x? It is taking y is a function of x. Like in mathematics you are writing, right? Y is equal to f of x. Okay. Or f of x is equal to y. Or f of x is equal to x square. Right? So it is modeling a variable y as a function of f of x. And it is keeping the data in z. Right? So when I print this particular value of z, so it will show you a equation. For example, let me run this code. And while running this code, R provides you two different features. Like you know about the difference between an interpreter and a compiler. Interpreter executes line by line. So if I go to my console and let me clear my console, if I put my cursor in the line number 1 and if I click run, so it will execute line number 1 and move to line number 2. When I click run, it will go to line number 3. When I click run again, it is going to line number 3. When I click the next, it is going to print the values. So it is generating a straight line equation. Straight line equation, all of you know, it is called as y is equal to mx plus c. Okay. So here, what it says, the m value is 0.6438 and c value is 26.780. So if I want to establish the relationship between two variables, in which one variable is dependent on another variable, right? For example, if I tell you here y is equal to x square. Okay. So in this case, which one is the dependent variable? Dependent variable is your y. Because until unless you don't know the what is the value of x, you cannot determine the value of y. For example, if I say x is equal to 5, then you will say x is equal to 5 indicates that y is equal to 5 square, which is equal to 25. So x is treated as my independent variable, y is treated as my dependent variable. So when I establish the relationship between y and x through this function lm by x, what it is showing? It is showing the straight line equation, that is y is equal to mx plus c, where you found the value of m and value of c. So this way you can establish the relationship and you can get the coefficient of slope as well as the intercept. In straight line equation we are using, right, slope and intercept. That value you can get by writing linear model function where it is y tilde character x. And R provides another interesting command that is called a summary. So instead of writing this print, if I write summary, then R is giving me the more detailed about that particular relationship. So for example, if I write print summary z, okay, and I told you how to use interpreter, but if you want to execute whole code at a time, simply you select all, click run, or in this source, there is a source with echo. If you click source with echo, it is going to execute the entire code. So if you click source with echo and the entire code is executed, and you can see what is the use of this summary command. Summary command is giving you in detail about that particular relationship. Right? What are the details you are getting? You are getting residual. Residual is nothing but the predicted value and actual value difference. So in fact, it is actual value minus predicted value is considered as your residual. Similarly, you are getting coefficient values here. In coefficient values, you can get what is the estimate value, what is the standard error, what is the t value, what is the p value, and also you can get residual standard error multiple R squared value, adjust R squared value, F statistics value, P value, and degree of freedom. So with the simple command summary, you can get the details about that particular relationship. But I'll not tell you about detail about this, what is the meaning of this one. Some of these things I'll tell you, but I'll not tell each and every part because it will deviate our discussion. So for example, residual. So residual is nothing but, you can see if X is considered as my independent variable, Y is considered my dependent variable. What it indicates? If X is equal to 95, Y is equal to 85, right? That it indicates. X is equal to 95, it indicates that Y is equal to 85. But when I train a particular model, or when I build a particular model, the model is not going to take the model is not going to check individual values to give you the prediction. Rather than the model is designed by taking the data, and the model is going to suggest you the recommendation based upon the collective effort of this particular data, rather than the individual data, right? So for example, if you see 95, it is coming 18. So in this case, if you see, if I show you how it is coming, so you can calculate here also. For example, if I take Y is equal to mx plus c, where we got m is equal to 0.6438 and c we got is 26.7808. So you can check this one. These two values we already got here. Okay, one is 0.6438, another is 26.7808, right? So Y is equal to mx plus c. So now, if you see the first data is shows that X is equal to 95 is Y is equal to 85. So I am taking X is equal to 95. So my Y value is equal to 85. This is the actual data. When X is equal to 85, Y is equal to X is equal to 95, Y is equal to 85. But if I put this X value here, then I'll get the predicted data. So Y is equal to, if I do, M is equal to 0.6438 multiplied by X is equal to 95 plus C is equal to 26.7808. Okay. Can anybody calculate and tell me what is this value we are getting? Y is equal to 0.6438. Okay. Y is equal to 0.6438 multiplied by 95 plus 26.7808. What is the value you are getting? Can anybody respond or write in the chat box?
$87.9418.
Yeah, thank you. So you will get 87.9418. Right? So this data is what? This is nothing but your predicted data, right? How you got this predicted data? Because of this equation, right? Y is equal to mx plus c. How you got this Y is equal to mx plus c? You got this Y is equal to mx plus c, okay, by taking the data of 5 different values that we have taken. X is equal to c vector, c function of 5 values, Y is equal to c function of 5 values. Based upon that, we calculate it. But now I am not going to check. If I go and check the matching, then definitely I'll return Y is equal to 85. When you give X is equal to 95, it is going to return Y is equal to 85. But I'm not checking. I'm not doing matchmaking process, right? Rather than I build a model using Y is equal to mx plus c, and using this Y is equal to mx plus c, I'm going to do prediction. So my predicted value I am getting here is 87.94818. But what is my actual value? Actual value is 85. So the difference between the actual value and predicted value, if I calculate actual minus predicted value, so what I am getting, actual value is 85, predicted value is 87.9418, right? So what is the residual you are getting? Minus 2.9418. Okay. Or in data science term or statistics term, sometimes instead of saying that this is a residual, okay, this is a residual, we say error. So, but in normally error is calculated as a modulus of actual minus predicted, or you can say predicted minus actual, right? So you will get the value is 2.9418, but residual is calculated as actual minus predicted value. So this value is minus 2.9418, which you can find in R here. minus 2.9418. Okay, you will get slightly difference, right? Because based upon the number of digits we are considering, we will find a difference. Okay, so similarly, if I put 85 into this equation, I will get a value which is deviating from 95 by 13.49. So as I am taking 5 different samples, these are the deviation from the actual value. So I hope you have understood what is the meaning of residual, right? Similarly, for each and every calculations, you will get, you have a mathematical conditions. Based upon that, you can calculate. But the most important part is called as the p-value. Okay, in statistics, one of the important concept is called as confidence interval, right? Confidence interval. If you go to confidence interval, normally, if you are a mathematics student or a researcher, then definitely you have a good knowledge in confidence interval. So normally we use 95% confidence interval, right? Why we are taking 95% confidence interval? The reason is that we accept the error up to 5%. So 95% means remaining is 5%, right? So if error is coming below 5%, then we accept it. But if error is above 5%, then we cannot say that it is a 95% confidence interval. Like you are telling a fact, right? You are saying that I studied R programming or SPSS or Python with 90% confidence. That means what? If I ask you 10 questions, then you can answer 9 questions. So you are estimating yourself that you are not going to answer one question, right? So normally we take in statistics is 95% confidence interval. So if you take this is 0.95, okay, so it will be 0.05. So if the p-value is below 0.05, then it is accepted. Okay, but if p-value is above 0.05, then it is rejected. Okay, because if p-value is greater than 0.05, it is not satisfying the criteria of 95% confidence interval. Right? That's why we are rejecting. So in this calculation, you can see in our calculation, we got the p-value as 0.1945. So it is much greater than 0.05. So what we can say, the relationship between x and y is insignificant. The relationship between x and y is insignificant. But if I get a p-value which is below 0.05, then I can say there is a significant relationship between x and y. So when we are dealing with a data set, we calculate the relationship between different variables. Suppose I will give a data set with 100 features, right? You cannot process 100 features. Your computer may not support to execute 100 features. So what you will say, instead of taking these 100 features, I want to take, let's say, only 10 features. So which feature to include, which vector to exclude, that also can be determined by checking the relationship between two variables. Right? If two variables are having relationship, having somehow related, so we can skip one of the variable. But if they are not significant, then we need to keep it them separately. We cannot exclude this one. So that's why p-value is calculated. Another interesting part is called as degree of freedom. So normally the degree of freedom is calculated based on how many samples you have taken. Like here I have taken 5 different samples, and how many variables you have taken. I have taken 2 variables x and y, okay, and I have taken 5 different variables. So 5 minus 2, which is equal to 3. So degree of freedom is equal to 3. So this way I can calculate the degree of freedom. Like that, for every calculations you have some mathematical measure behind this one. You need to understand whenever you are doing the statistical analysis. Okay. So I'll save this code. Those who are interested, you can copy this code and keep with you. So later point of time, you can install R if you have not installed, and you can see the performance. Okay. Now, suppose I want to do the prediction, right? For example, I will go for prediction. For example, somebody will give me a value of X. Like somebody will say that you have taken the values 95, 85, 80, 70, and 60. So 65 is not there. So suppose I want to predict for 65. If my X value is 65, then what may be the value for Y? So for that, what I need? I need prediction. So how to do prediction? In order to do the prediction, in R support a predict function. So what I'm going to do after establishing this particular relationship, I will create data dot frame. I already told you data frame is used to represent in a tabular structure in which I am supplying x value is equal to 65, right? And let me keep in a variable called as a. Any variable you can write, right? Now I want to predict using this predict function in which I am supplying the relation. Relation is stored in Z and data is available in A. And let us keep in this in another variable called B. And if I print the value B, then what it will give? It will give me the prediction. So I have declared a data frame. Why I have declared a data frame? I want to represent in a tabular structure. Then I am supplying x is equal to 65. Okay, that I am keeping in A. And a predict function is used in which I am using Z, right? Z is the nothing but the relationship between y and x, and A is nothing but where the data is available. And I am keeping in B. Finally, I am printing B. So if I run this code, so it is saying if your x value is 65, so your y value is 68.63014. How it is calculated? Again, y is equal to mx plus c, where I told you what is the value for m. M is equal to, we already calculated, right? M is equal to something and c is equal to something. If you put that value, you will get what is the value of y. So this way you can do the prediction. And many people also applied different kind of visualization technique. Like I want to see the relationship between x and y in terms of a graph, right? Normally we draw line chart, bar chart, pie chart, scatter chart, box plot, and so many other things, histogram and other things, right? For showing the relationship between different type of variables, right? So if you want to show the relationship between variable, okay. Before that, let me share this code with you in chat box. Okay, so we'll see that how to go for representing these things graphically, right? So for example, if I go for graphically, so I will use a function called PNG, right? PNG function is used in the R to create a chart file. Not necessary that if you want a chart file or a picture of extension.png, you will use PNG function. Even if you require JPG or any image format, JPG, BMP, all these formats, you are going to use the PNG function. For example, I have created a PNG function. I have used PNG function, and I am mentioning file is equal to let's say relation dot JPG. So it will create a image file with the name of relation.jpg. And note that the default directory of R is our document folder. You know, in computer we have a document folder. So the default directory of R is my document folder. So any graphical output you are generating, that graphical output is stored in this particular folder, right? So now PNG file is equal to relation.jpg I have created. I have already established the relationship here. Now I want to plot. Let me delete this part, prediction part. So I want to plot. So for example, I want to plot y with x, and I want to use a function called as AB line. If I want to a straight line that establish the relationship between two variables, so I am using AB line. AB line is a function that is used to add the straight line into the graph. So I am using AB line, then LM y tilde character x. Okay, y tilde character x. So this is nothing but my relation, right? So with this, it is going to draw a line, right? And any chart file which you have created using PNG function, so that need to be saved using debug. Debug is used to save the file. So if you run this code, you can see your document folder, right? This is my document folder in which there is no images there. Okay, there is no image present here. So whenever I am running this file, So you can see there is an image created which is relation.jpg. And if you open this image, what you can get is that there are 5 different points you have, right? X. It is taking the one feature X in x-axis. It is taking another feature in the y-axis, right? And it is plotting a particular line that closely fit with all the objects. So whenever we do some kind of analysis like regression analysis, we normally draw a line that closely fit with our data. So you can see all these data points that is shown in a circle. So that is fit with this particular straight line. Okay. So all these image files will be stored in your document folder. So you have to see these images from the document folder. So this way you can perform the linear regression analysis or establishing the relationship between two variables. Yeah, anybody having any questions related to this, you can ask. Any question up to this? Okay, so somebody can ask that here that you have taken only 2 variables, but why don't you take multiple variables? So for examples, I want to take another variable, let it be z. Okay, or I'll show you in another file. Let me save this code. Okay, so for example, I want to take more than one variable. For example, I'm taking x is equal to another set of variable, let it be 3, 4, 5, 6 and 2, and y is equal to, let's say I'm taking 8, 5, 7, 3 and 1, and I'm taking another variable, let it be z. Z is equal to, let's say, minus 3.7 or 3.5 or 2.5, some random values you can try, 11.5 and 5.7. So this case what happened, I have taken the numeric vector, okay, but these numeric vectors are nothing but these are 3 different variables I have taken. Okay, x, y, z, 3 different type of variables I have taken, right? So now what I want to do, I want to establish the relationship between these variables. So normally whenever you are establishing a relation, okay, sorry, I missed the C function. Okay, so I have used 3 different variables. So when you establish a relationship between multiple variables, so one variable is treated as dependent variable and rest variables are considered as independent variable. For example, I can say, let's say a function like this, y is equal to, let's say y is equal to, suppose I will write here b plus b0 plus b1 x1 plus b2 x2. So in this case, this x1 and x2 are treated as my independent variable, whereas y is considered as my dependent variable. Okay, one is considered as independent variable and one is called two are considered as an independent variable, that is x1 x2, and y is considered as my dependent variable. So with the given x1 x2 value, it is going to give you the value for y, and these coefficient values also you need to determine, right? So if I want to establish the relationship here, so what I will write here in R, that is, I can write relation is equal to any variable you can use. Relation is equal to, I'm using this linear model function. This linear model function is nothing but I can say z is my dependent variable, which is a function of x plus y. Okay, and I'm going to print the relation, right? So if you run this code, error in printer relation. Okay, if I run this code, then here I am getting the coefficient for x and coefficient for y and the intercept value, right? Like here you can see I have 3 variables. and three coefficients. One is B0 is a coefficient, B1 is a coefficient, and B2 is a coefficient. Where B1, B2 are the coefficients of x1 and x2 respectively, and B0 is a coefficient. So here I am dealing with the multiple regression. So in which I have two independent variables and one dependent variable. So if you see here that it is displaying the coefficient of x, coefficient of y, and the intercept y, right? And if you want to know about more about this relationship, you can write summary of the relation. That will give you the detailed relations about these three variables x, y, z. Now you know what is the meaning of residuals. I already told you, right? Residual is the difference between the actual value and the predicted value. And it is showing that different coefficient, x coefficient, y coefficient, and intercept, and it is showing the significance of different pores. So in order to easily recognize whether you are satisfying the criteria of the p-value, like I told you, p-value is less than 0.05, whether you are satisfying the criteria of 0.05 or not, that you can check from the significance score. What it indicates, if you are getting a triple star here, the triple star means the value which you are getting, that is in the range of 0 to 0.001. But if you are getting 2 star, that indicates that the value lies in between 0.001 to 0.01. Similarly, if there is a single star, it represents 0.1 to 0.5. So whether you are getting a 3 star or a 2 star or a 1 star, all are accepted. Okay. So, but if you are getting a dot, if the value is in between 0.05 to 1, then it is not acceptable because it is greater than 0.05. Similarly, if you are getting 0.1 to 1, so that is also not acceptable, and it is represented in the form of blank space. So in this case, as we are getting all 3 stars, what it indicates? It indicates that the relationship between z with x and z with y, or z with the combination of x and y, that satisfies the, there is a significant relationship between these. This is impacting, right? They are not insignificant, right? And also you can see in this case, I have taken the same 5 sample, but I have taken 3 variables. So 5 minus 3 is nothing but my degree of freedom. So I am getting the value as 2 degree of freedom. So this way you can do the analysis when you are dealing with 2 variables or more than 2 variables. Okay, so next I'll tell you about how to do using a data set. So as I am typing this value, right, when you deal with a very large data set, it is very difficult to type the values, right, rather than you will directly take the data set. So I'll show you the same relationship using a predefined data set that is available in R, and the data set name is called as empty cars. So this empty cars data set, MTCARS, this is the name of the data set, which is a predefined data set. So whenever you install R, some of the basic data sets are also available in your system that you can utilize. So here I'm using empty car data set that is available in R environment. No need to export this data set into your environment. Although if you are implementing in your research domain, your data set is not available in R environment, so you have to export it. But for the existing data set, you can directly use it. So what is this data set? What is the meaning of this data set? Let me show you this data set so that you will get a clarity. Suppose if I write input is equal to empty cars. So if I run it, then you can see in my environment, input is created, which shows that there are 32 observations of 11 variables. That means the dimension of this particular data set is 32 cross 11. Okay, the dimension of this data set is 32 cross 11. So if I open this data set, so this is the data set, where you can see there are 32 rows are there and 11 columns are there. What it shows, it gives a comparison between different car models. These are the different car models. Okay, you can see these are different type of car models. So it is comparing these car models in terms of 11 different features. Some of the features are MPG. MPG stands for miles per gallon. DASP stands for displacement. HP stands for horsepower. WT stands for weight, and so on. AM stands for whether the vehicle is automatic or manual. So these are the data sets. These are the values that are given in the data set. Now, in these data sets, suppose I want to establish the relationship. Okay, so what I'll do, or there is another command that you can use here. For example, if I write head of input, so that will show you the sum of the initial rows of the data set. Like this is the data set which I showed you, but when you write head of input, it is showing only first 6 rows of the data set with 11 different features and 6 different cars, and it is comparing 6 different cars with 11 different features. Now, if I want to take only some of the columns in the data set, I'm not interested in, let's say, all the 11 you can say columns or features. I'm interested only some of the features. So I need to crop this data set because I don't need everything. So I can write here, let's say input is equal to empty cars in the data set. I want to crop the data set. So in cropping the data set, you need to mention how many rows you want to take and how many columns you want to take. If you want to specify that I want to take all the rows, then you simply leave the row, because before comma it is representing the row, after comma it is representing the column. So I want to take all the rows, that's why I'm not writing anything. I want to take some specific column that I'm mentioning as a vector. Okay, for example, here I'm mentioning as MPG. I want to take this miles per gallon, and I have to take DISP, displacement. I have to take, let's say, HP, horsepower, and I want to take WT, weight of the car. Right? So this MPG, DISP, HP, and WT, these are the 4 columns that need to be cropped from the data set, and it will store in input. Earlier input is having empty cars, the entire data set, but now the input is having only 4 different features. So let me run this one. So you can see in the environment, it is having all 32 car models, but it is only having 4 different variables. Okay, so now what I can do, if I want to do analysis among these variables, right? So I told you when you are taking multiple variables, one of the variable is considered as dependent variable, rest variables are considered as independent variable. So if I do, let's say model is equal to, I'm using lm is the linear model function, in which I'm writing mpg is a function of DISP plus horsepower plus WT, and data is equal to input, right? So data is present in the input, and I'm taking mpg is a function of DISP, HP, and WT, but indicates that DISP, HP, and WT, these are nothing but my independent variables, and mpg is considered as my dependent variable, right? So if I want to print my model, it will give the coefficient values. So you can see the coefficient of DISP, I'm getting minus 0.00937, HP is minus 0.031157, WT is minus 3.80089, and intercept value is this one. Right? This value we are getting. Right? So, but instead of writing print model, if I go for summary of the model, so I'll get a detailed relationship about this particular model. For example, here you can see that this is a detailed relationship. You are getting residuals. So here you are getting residual in terms of 5-number summary. What is 5-number summary? So let me discuss. That is having a statistical significance. So the meaning of 5-number summary is that there are 5 different values we are using while summarizing the data. What are the 5 values that we are using is considered as, first one is considered as minimum value. Second one is considered as quartile 1. Third one is considered as quartile 2, or we also call this as median. Fourth one is considered as quartile 3. Fifth one is called as maximum. Okay, so these are considered as 5-number summary. So let us take a small data set to understand. For example, you have a features like for a particular features you have a value like 2, 6, 7, 8, 8, 11, let's say 12, 13, 14, 15, 22, and 23. Right? This is the feature value of a particular specified feature. And how many values I have taken? I have taken 12 values. Now, what is the minimum value here? What is the minimum value here? The minimum value is 2. And what is the maximum value? 23. So 2 is considered as minimum value. 23 is considered as maximum. Now, what is the median? In this case, if you calculate the median is nothing but the mid values. And make sure that while you are calculating median, they are in sorted order. Okay. If they are not in sorted order, you have to sort it. Either increasing order or decreasing order or non-increasing order or non-decreasing order. Right. So now, if you see, if I calculate the median, in this case, the median is nothing but the mid value. So there are 12 elements are there. So 5 elements in the left, another 5 elements in the right. So it will be the middle 2 elements average. That is 11 plus 12 divided by 2. So I'll get the median is 11.5. So I got this value as 11.5. Right? Now, if you go for quartile 1, if I divide this data set into 2 parts, then first part is having 2, 6, 7, 8, 8, 11. Second part of the data set is 12, 13, 14, 15, 22, and 23. Right? I splitted the data set into 2 equal halves. Now, in this data set, if I want to find the median, so you will get 7 plus 8 divided by 2, which is equal to 7.5. These two values average. Like here we calculate these two values average. Similarly, mid values, if you calculate here, the median is equal to 14 plus 15 divided by 2, which is equal to 14.5. So this is my 14.5. This is my 7.5. So these 5 values are considered as 5-number summary. So normally in the data visualization technique, we have a technique called as box plot. Box plot is drawn based upon this 5-number summary, and box plot looks like this one. Where this value is considered as the minimum value, this value is considered as the maximum value, this is considered as quartile 1, quartile 2, and quartile 3. Yeah, anybody having any question? Somebody has raised the hand.
Devashisha Praharaj, do you have some question? You can please go ahead.
Okay. So this is the way we draw a box plot. Okay, box plot shows the minimum value, quartile 1, quartile 2, quartile 3, maximum. Okay, and box plot is also used to find if any outlier in the data set. So what is an outlier? The simple example of outlier is that, let's say for a particular subject, let's say resource methodology. Okay, all students secured the marks in between 40 to 60. but one of the students secured 99. So this 99 is very far away from all the students' marks. So we consider this as an outlier. Because if I consider this outlier into consideration, that will impact my analysis. So while we are doing the box plot, we are checking that what is the interquartile range. For example, in this case, we got quartile 1 is equal to 7.5, quartile 2 is equal to 11.5, quartile 3 is equal to 14.5, right? So in order to check that whether any outlier is there or not, first you need to find interquartile range, that is called as IQR. Interquartile range is nothing but Q3 minus Q1. So Q3 is 14.5 minus Q1 is 7.5. So I'll get the value as 7, right? And you need to find Q1 minus 1.5 times of IQR. On the other hand, you need to find Q3 plus 1.5 times of IQR. For example, if I do here 7.5 minus 1.5 times of IQR, IQR is 7. Q3 case it is 14.5 plus 1.5 into IQR is my 7. So I need to calculate 7.5 minus 1.5 times of 7 and 14.5 plus 1.5 times of 7. So what is the value we are getting here? 7.5 minus 1.5 into 7. So you will get minus 3, right? Similarly, if you take quartile 3 side, it is 14.5. Okay, it is 14.5. So it is 14.5 plus 1.5 into 7. So I am getting 25. So any value you are finding beyond this particular range, minus 3, or you can say less than minus 3 or greater than 25, that is considered as outlier. But in your data, in our data, whatever I have taken, none of the value is less than minus 3 and none of the value is greater than 25. Okay, so there is no outlier in your data set. But if any outlier is there, you can identify it. So I told you this thing, this 5-number summary, because in this regression, you can see when the number of data are more, the residual is not represented individually. Like previous, it is showing with respect to sample 1, sample 2, up to sample 5. But when the data set is large, so in that case, the residual is represented in the form of 5-number summary. And also, you can see the significance of code here. Like DISP case, you are getting a blank. What this blank indicate? The blank indicates the value which you are getting here. It is in between 0.1 to 1. And star indicates that the value is in between 0.01 to 0.05. 2 star indicates it is between 0.001 to 0.01. Right? So what it indicates overall, it indicates that whenever you are taking MPG against DISP, HP and WT, DISP is not at all impacting. DISP is not at all impacting. But HP and WT is impacting the MPG. Okay. In order to decide that miles per gallon, if you see what are the dependency of miles per gallon with other variables, you will find HPW is contributing, but DISP is not at all contributing. Right? But the overall p-value we are getting is 8.65 e to the power minus 11, which is much smaller than 0.05. So what we can say, overall, if I take DISP plus HP plus WT, it has significance. Okay, so this way you can go for 2 variables, 3 variables. I have shown the 2 variables, 3 variables, and 1 variable. So you can establish the relationship with multiple variables. Okay. So mostly whatever data we did till now is considered as I can say these data are nothing but numerical data. These data, whatever I have taken for empty cars, if you see these data also. These data are nothing but the numerical data, although some categorical data are there, but they are also represented in the form of 0 and 1, right? So, but there are different type of regression techniques or relationships we need to establish when it is in categorical data. Okay, so categorical data is more important. Sometimes you are given with marital status, or you are given with blood groups, you are given with eye colors. In that case, you have to deal with categorical data. There, if you apply this type of relationship, it may not work, right? So based upon the type of variables, you can decide whether to go for categorical data or you have to go for numerical data. Okay, so for the completion of this lecture, what I'll do, I'll show you one example with categorical data. For example, you can see this is the my data set in which you can see AM, or you can say VS. AM stands for automatic or manual. Nowadays vehicles are automatic, right? Early days the vehicles are manual, cars are manual, right? So suppose I am taking AM. AM is 0 and 1, automatic or manual, 0 and 1. So what we can do here, that transmission mode is either manual or automatic, that I'll consider as a dependent variable. And I am going to check that whether this automatic, whether a vehicle is automatic or manual, is it dependent on the other variables like horsepower, weight, and cycle. Okay, so let us try this one. So what I'll do here, instead of taking all these parameters, I'm going to take different parameters. So let me delete these parameters. I'll take one parameter, that is automatic manual, and I'm checking with automatic manual with the cylinder, number of cylinders present in the car, and horsepower, and WT. Okay, input is equal to, I'm now cropping the data set. If you want to see the data set also, you can see here by writing head info. Okay, let me run these 4 lines of code only. Yeah, this is my original data set, but I am interested in only 4 features, that is automatic manual, CYL, HP, and WT. So I am cropping that particular data set. This is my data set. Right. Now I want to establish the relationship here. Here I cannot use this LM function because LM function is used for what? LM function is used for linear model function. It is for numerical data. So if you want to go for categorical data, there is a function called GLM. In GLM, I'll mention the formula is automatic manual is a function of CYL plus HP plus WT. And data is available in input. And in such type of case, we are using a type of regression that is called as logistic regression. Or in that case, logistic regression case, we write family is equal to binomial. Okay. So when you are dealing with categorical data, then you have to apply logistic regression rather than applying the multiple regression or linear regression. So in logistic regression implementation, we are writing family is equal to binomial, right? So if I write print summary model, let me clear my console, and if I run the entire code, you can see this is the relationship. What it's saying, in case dot is also, dot indicates that the value is in between 0.05 to 0.1, right? Or no? And if you see this star is also, star is means the value is below 0.05, and blank indicates the value is greater than 0.05. So we have seen that the p value in the last column, if you see, is more than 0.05 for the variable specifically CYL and HP. These two variable case, it is more than 0.05. So what we can do, we consider them insignificant. These variables are insignificant in contributing the variable automatic or manual. However, WT has a importance, impact the automatic or manual in the model because its p-value is below 0.05. So this type of statistical analysis you can do when you are looking for quantitative analysis. Okay, so this gives a rough idea about R, but I'll also tell you about the Python, because I told you about SPSS. SPSS is not open source. We have also explored R. Now we'll go for a few time for Python. So I told you it is not necessary to learn all these things. Based upon your application, you can decide whether you are going to use SPSS if your institute is having subscription. Otherwise, R and Pythons are open source that you can use, right? So Python is very popular language for data science or machine learning applications, and it is widely used irrespective of the different type of applications. Like those people are working in web application or image processing application, enterprise application, 3D CAD application, audio and video based application, business applications, software development. All these people are using the Python. So Python is a very popular language, right? So Python is very simple. You need not install anything in your system. If you want to install, you can install PyCharm, one of the popular editor or IDE, you can say, integrated development environment, into your system, and you can do the statistical analysis. As an alternative, what you can do, you can go for Google Colab. Like here, I have opened Google Colab. You can simply create Google Colab file. You type Google Colab, and this is Google Colab window, right? Here you can write your code, you can run your code, right? And if you want to do a bigger computations, in bigger computation case, you need to purchase the computing resources from the Google Colab. Okay, it is also very simple Python. Like I want to print a message, let's say print BPUT that the way I did for R, the same way I can write a statement, and there is no need to specify any specific semicolon. And if you click this button, it is going to run this code and display the output, right? Now, how to do statistical analysis, that is more important, right? So like most of the statistic case, sometimes we generate a random number. Okay, in statistical analysis, we generate a random number. So in order to go for statistical analysis using Python, there are different type of modules are there, like random module is there, statistics module is there, SPSS module is there, that you can utilize for implementing or finding different kind of statistical environment. So what I'll do, I'll show you some module. I'll not go through all the modules due to lack of time. So I can write import random. So it is a package that is available in R. So I'm using import random. And if I print a random number, sometimes we want to generate a random number in the range of 0 to 1. So I can write import random and print random.random. So you can see it is going to print a random number. In many applications, we are using random number generation. So you can simply generate a random number by writing 2 lines of code. And if you want to specify, I want to represent, I want to print the random number in a particular range. For example, let us say, let us take an integer, random dot rand int. I want to print a value in the range of 10 to 20. So here you can see it is displaying a value which is in the range of 10 to 20, and it is a random number, right? Similarly, somebody can write if I want a value between 50 to 100, if I run this code, it will generate a value in between 50 to 100, right? Similarly, you can decide if you have a set of random values, from that random value you want to generate, that also you can generate. For example, I'll take 1, 5, 10, 15, 20, and out of these I want to choose a random number, that also I can do. So that is the reason why people are using the random number. But some applications we can see that whenever I'm generating in different iterations, I'm generating the random number is different. So in order to restrict that random number, you can write random.seed, let's say 2. So in this case, what happens, if you run this code, you can see the first, now the random numbers are not changing. Because if you want to evaluate different type of model with the same random number, so if random number is changed, it is going to impact. But when I am writing random seed, okay, so if you use this same seed value twice, then you will get also the same random number. So if you want to stick to a particular random number, you can utilize it. In the similar fashion, we have a package called as statistics in Python. So import statistics. Okay. Suppose you are giving a set of values. For example, I am taking a data sets with a set of values, let's say 5, 2, 7, 4, 2, 6, and 8. And I want to print the mean of x. Oh, okay. I want to print the mean of x. Okay. So for printing this x, which is having the mean, I can write x is equal to statistics dot mean of these data sets. So it is going to take this data set and calculate the mean value and displaying that mean value. So you know mean, median, these are the very popular measures. Similarly, if I want median, okay, if I want median, so what I will do, instead of writing mean, there is another function for median that I have to use, right? For example, I will use statistics median. So it will give the median. Median is nothing but the mid value, but these values are not in sorted order. So first I need to sort them in a order, then I am going to find the median of the value. Similarly, mode, you know, right? Mode is another statistical measure. So if I write mode and run this code, then the maximum time mode shows that how many times, what is the maximum number of times a particular value is repeated. So maximum number of times 2 is repeated, that is twice, and 2 times, so it is showing mode is 2. Similarly, you can use another function called standard deviation, which is STDEV. STDEV is used to calculate the standard deviation of these measures, right? Similarly, there are several type of measures that are available under this random statistics and SPSS package that you can explore for statistical analysis. Okay, to summarize this lecture, what we have discussed, we started with what is quantitative analysis and what is qualitative analysis. We differentiate these two. And we also discuss about 3 different statistical packages. In depth, we discussed about R, but I also given a highlight about SPSS and Python. So try to explore all these things if you are interested in the statistical analysis or quantitative analysis when you are carrying out the research. Okay, so this is all from my side. So if you have any further question, you can ask.
Any more questions from the participant? Hope there is no questions from the participant. Thank you, sir, for your time and expertise and you are sharing with us today. And we are eagerly waiting for your next session, which is going to be held on tomorrow. So now we will have our lunch break. So next session will start at 3 p.m. So all the participants can leave the session and should be connected at 2:55 p.m. Thank you all.
Thank you.
Thank you, sir.
You today with us, Sanjaya Kumar sir. Tomorrow there is a session 8 which will be taken by Dr. Sanjaya Panda tomorrow instead of Vikramaditya sir. Okay, and the Vikramaditya sir session will be seated at the last when the Sanjaya Panda session is there. Okay, it is to inform to all the participants. Thank you.